Hello dear learners, today I welcome you for lesson 4 of chapter 2, that is Kinematics. Here is the contact information. If you face any difficulty in this lesson, you can contact me. The learning outcomes which we are going to cover in today's lesson are plot and interpret a displacement time graph. You should be able to deduce information about motion from the shape of a displacement time graph. Now the contents which we are going to cover in today's lesson are that how to plot a graph, plot of displacement time graph, deduce information from the graph, and practice questions. So, how to plot a graph? Steps for plotting a graph are mentioned here. We will see one by one these steps. To plot a graph, one must have at least data of two physical quantities, or you can say data of two variables. Whenever you plot a two-dimensional graph or 2D graph, in that case you have two variables, one on vertical axis and the other quantity on horizontal axis. So those variables can be two physical quantities. So let's see that once we are having two physical quantities, then we must determine the range of data of particular physical quantity. If we have any physical quantity, then we must determine the range of that data, that how much range of that physical quantity we have. After that, label each axis with particular physical quantity. It is necessary that you have to label each axis. Either you are having vertical axis or horizontal axis, you must label that axis with that particular physical quantity. If you are taking time on horizontal axis, then you have to label there that you are taking time on horizontal axis, and you have to mention that what units you are taking that quantity, either in meter, seconds, kilometers, and so whatever the quantity is, according to that you have to define the units. Then also assign title of the graph. Most of us miss this thing that we don't assign title of the graph. If we don't assign title of the graph, then any other person who is going to check that graph, he will be unable to uh, notice this thing, that what this graph is about. So after that, set the scale according to the range of data. Whatever the range of data you have to set the scale for that range. And after that, determine the data points on the graph and then join the data points to plot the graph. Now let's move towards online whiteboard to plot the given data. Here I have two physical quantities if you see in this data, and our first step is that we must have at least two physical quantities in case of two-dimensional graph. So I am going to plot two-dimensional graph or 2D graph, you can say. So I have two physical quantities. Time is physical quantity and its SI unit is second. And the other physical quantity is displacement. Its SI unit is meter. So I have two physical quantities. So after that, I must know the range of data for that particular physical quantity. So range of data is also given here. If you see, for time, I have maximum range here is 5 and minimum is 0. So total range of this time physical quantity is 5. And for displacement, I have range till 50, 0 to 50. So after that, what I do, I will plot two axes. One is vertical and the other one is horizontal. Then I will label each axis with these particular physical quantities. And here I will tell you one point. Let's move towards whiteboard first. Here I have a graph. So first I am going to plot the axis. I'm not having any negative value, so that's why I'm taking it from here. So this is my vertical axis. Let me increase its weight so that it will be clearly visible to you. And now I am going to plot horizontal axis. So now the question is here that which quantity or which variable we are going to take on horizontal axis, or and which quantity we are going to take on vertical axis. This is very important. So remember one thing, that whenever we have to take one quantity on horizontal axis, that quantity is going to be the independent one, and the dependent quantity is going to be on vertical axis, because this side, whatever the quantity or variable we are taking on this axis, that quantity is going to be dependent on horizontal axis. So in my case, the example which I have taken, in that example, time is independent, displacement is dependent, and displacement is dependent on time. So I am going to label the axis here, time in seconds. And on other side, that is vertical axis, here I am going to take displacement, and displacement will be in meter. So now I have maximum range of this time axis, that is 5 seconds. So now I am going to mark the data points here. And before this thing, again I will say that I am also going to miss that point, that what is the title of this graph. We must assign title of the graph. So title will be that it is displacement time graph, because you have on one axis displacement and the other on other side we have time. So I will write here the title, that is displacement time graph. So if anybody is going to check this graph, before going to see these axes, he will see this title, he will get an idea that this graph is about displacement time graph. So that's why it is important that you must assign the title also while plotting the graphs. So now let's move towards scale. Now we have to set the scale according to the range. And if you see my slides, again I move towards the data which I have to plot. Here I have time, and time is from 0 to 5 seconds. So this is the range. And if you see at what increment it is changing, or what the change is coming. So here every second displacement is changing. So 0, 1, 2, I have the jump of 1, or you can say increment of 1 here for time axis. And on displacement, what is happening, that I have increment of 2. So at every second displacement is increasing, and that increase is 10 meter. So let's see. I am going to first set the scale. So I have how many big boxes? From this point, origin, till this, I have one big box. This is second, third, fourth, fifth, and sixth. So I can plot 6 seconds if I set the scale in such a way that I say that one big box on horizontal axis is equal to 1 second. So what I will do, I will say one big box on horizontal axis is equal to 1 second. So what I will do, I will take a mark from here and I will place the point here. 1 second, 2 second, 3 second, 4 and 5. Suppose if you are having time range from 0 to 10 and you are not having big boxes here on this axis 10, so you have to take these small boxes. Then you can say that two small boxes on horizontal axis is equal to 1, then it will be 2, 4, and so and so. So as the range is going to vary, according to that you have to set the scale. So now I have to mark the points here. This is my origin. I said 0. Here I have 1 second time. Here I have 2 second time. Here I have 3 second time. Then 4 second time. And here I have 5 seconds time. You can take more range as well if you need. So now on vertical axis the scale will be, you know that we are having the increment of 10. So I will say that one, sorry, let's see that I have so many boxes there or not. So one big box, second, third, fourth. So what I can do, 0, 10, 20, 30 and 40. So I am unable to plot here till 50 to take the marks till 50. So now instead of taking one big box on vertical axis is equal to 10, I will say that one small box is equal to 5 meter, or you can say that two small boxes on vertical axis is equal to 10 meter. So here it will be 10, 20, 30, 40 and 50. So while marking the points of range of data, you must set the scale. If you are selecting the scale appropriately, then there are very few chances of mistake. So I will say two small boxes on vertical axis is equal to 10 meter. So now let's see. I mark the points there. This will be 10, sorry, 10, 20, 30 meter, 40 meter and 50 meter. Here I have 0, that is of origin. Here I have 10, then 20, 30, 40, and here I have 50. So now the next point is that we have to determine the data points. So what I will do now, that I will mark the data points here. So if you see that at 0 we were having 0 meter, so here it is 0, and at 1 second time I am having displacement of 10. I am having displacement of 10. I will mark a point here. At 2 second time I am having displacement 20. So we will see that where the intersection is going to occur. So it is here. Again, at 3 second I was having 30 meter displacement. At 4 second time I am having 40 displacement. At 5 seconds I have 50 meter displacement. So now after marking the data points, we have to join these data points. So put the scale, put the ruler, and join these points. So in online whiteboard, this is the limitation, that I can't use ruler here, so I will mark a line here. So might be possible it will be not a straight line. In this way, then to next point and next point, so that these points must be intersecting, or you can say in this way. We have to plot the graph. So now I hope so you can plot the graph of displacement time. Now the next objective was that we have to deduce the information from the graph. So if one graph is given to you, you can deduce information. If you see here, we have displacement, we have time, so we can calculate velocity. We can calculate velocity. If you recall the mathematical relationship of velocity, that is velocity is equal to displacement divided by time taken. So here in this graph, I am having displacement, I am having time, so I can calculate velocity. I can tell either the velocity is increasing or decreasing. I can tell that either velocity is increasing or decreasing uniformly or non-uniformly. So if I go back to this graph, my this the line which I have plotted here, it is indicating that velocity is increasing. Why velocity is increasing? If you see this mathematical relationship, displacement is directly proportional to velocity here. This displacement is directly proportional to this velocity. As displacement is increasing, velocity is going to increase. And this increase is uniform. Constantly velocity is increasing. Why constantly it is increasing? If you see, after every second there is a change in displacement, that is of 10, and constantly change is occurring. If you see from 0 to 1 how much displacement is changed, it is 10 meter. From 1 second to 2 second, how much change in displacement occurred, that is also 10 meter. If you take the difference of this change of displacement, it is 10 here. For next interval from 2 seconds to 3 second time, it is again what? 30 minus 20 gives you 10. So displacement is increasing constantly, because here it is 10, here 10, here 10, and here 10. So if you find the velocity for from time 0 to 1 second, it will be 10 meter per second. If you using this relationship, find out the velocity, it will be 10 meter per second, because here we have 10 divided by 1 second time, it gives you 10 meter per second. From 1 second to 2 seconds, how much velocity is there? 20 minus 10, it is giving you displacement 10 here. So this displacement 10 is occurring in 1 second. So again the velocity will be 10 meter per second. So we can say velocity is increasing but uniformly. Displacement is changing constantly. So this is the information which we can deduce from this graph. So I hope so you are now able to plot the graph and you are able to deduce information, or you can say you are able to interpret the information from the graph. Now let's move towards our slides. So we have plotted this data on online whiteboard. Now move towards next slide. Plot of displacement time graph. Car traveling with increasing velocity. Velocity is again increasing, but non-uniformly velocity is increasing. If you see, data is given to you, two physical quantities are given, time and displacement. So what you have to do, take independent quantity on horizontal axis and dependent quantity on vertical axis. So I have taken here what? I have plotted the graph, and I have taken here the scale that one big box is equal to 1 second. So I have plotted the range of this time axis on this. And on vertical axis, you can see that I have this range that I have to plot till 125. I have to mark till 125. So what I did, I have taken this as origin and I said that this one box is equal to 25 meter, then 50, 75, increment of 25 is occurring here, 100, then 125. So here one small box is indicating to 5, 0, 5, then 10, 15, 20 and 25. So after 25 again one small box is indicating to 5, so 25 here, 30, 35, 40, 45 and 50. So why we are saying that this here in this graph velocity is increasing but non-uniformly? Because if you see here, displacement is now not constantly changing. Here in first 1 second, what is happening? 5 meter displacement is changed. So velocity will be 5 meter per second for this. In next 1 second, what is happening? How much displacement is changing? 20 minus 5 gives you 15. So 15 divided by 1 second, apply this mathematical relationship, you will get velocity that is 15 meter per second, because at first 1 second you were having 5 meter per second velocity. See, this curve is increasing so shortly for short time. The gradient of this uh, line segment is not so much high as compared to this from 1 second to 2 seconds. There is a big slope, sharp rise is there. After 2 second to 3 second, if you see, we have 40 minus 25, it gives me 25. Here at first second I was having displacement 5, then I have displacement 15, then it is 25. It is increasing. So again, if you see here, we have velocity increased, and it is not increasing constantly. When we say that the difference is coming equally, for example, if here at first second I have 5 meter displacement change, and in next 1 second again I have 5 meter displacement change, then we can say it is constantly changing. But here we are having the change at every second, and that change is increasing, and it is non-uniformly increasing. Here the velocity is increasing non-uniformly. So now let's move towards next plot. Yes, now here you have to deduce information from the graph. Take few seconds and think that what is happening here. So if you see here, at first second I have point somewhere here, and what I did, again I taken one big box is equal to 25 meter on vertical axis, so one small box is indicating to 5 meter. So if you see that what will be this point, it will be 25 here, 30, 35 and 40. It is 45 meter at first second, or you can say at 1 second the displacement is 45 meter. Okay, then after one more second, that is 2 seconds, what is the displacement now? Here I have 75, so here it will be 80. This is the point here. So now you can say that what is happening, either it is increasing or decreasing. To check this thing, take the difference of displacement first. So at first second you have displacement what, 45 meter. Now at 2 seconds how much displacement is? It is 80. So take 80 difference here from this point to this, 80 minus 45, it gives you 35. So displacement is decreased here. If displacement is decreased, it means velocity is also decreased, because displacement is directly proportional to velocity. If this quantity is increasing, this will increase. If it is decreasing, it will decrease. So here displacement is decreased. You can see here as well in this way that this line segment is greater as compared to this line segment. So let's see that after 1 second, more 1 second, what is happening. At 3 second time, we have 100 here, and this is the point at this point, so it is 105. 105 minus 80, it is 25. So it is clearly indicating here that after every second displacement is decreasing. Here it was 45, 35, 25. So it is not constantly decreasing. There is a change. So it is decreasing non-uniformly. So I can uh, extract data points as well, or you can say the points of these, that what is on horizontal axis and what is on vertical axis, or in other words I can extract data for these two physical quantities by seeing this graph. And I can also explain here that either the velocity is increasing or decreasing. So in over this graph it is decreasing, and it is decreasing non-uniformly. Okay, if you see here the car traveling with, the motion of the car in this scenario is decreasing velocity, and this velocity is decreasing non-uniformly. So we say non-uniform velocity, and I have extracted the data here. At first second, why I have 45 meter displacement. At 2 second time, I have 80 meter displacement. At 3 second time, I have 105 meter displacement, and so and so. Now let's move towards next slide. Here you have to deduce the information by yourself now. This is the task for you. Here the car is at rest. Why it is rest? Because no change is occurring in the displacement for 5 seconds. At first second no change in displacement is there, it is just straight line. At next second no change, so till 5 seconds it is constant. So here the question can arise that why we have plotted at 20-meter displacement, why not at there here? So this is indicating that before this point the car might have covered 20-meter displacement. So when we started to measure that is there any change in velocity or in displacement, so from that onwards we are going to plot here, and that is constant. Suppose if I say that displacement is 30 for all the first 5-second time, then what will happen? You have to shift this here 30, because 30 might be the displacement which the car have covered previously, but in this 5 second it has covered no change in displacement, or no displacement is there. So here are the practice questions. Do it by yourself. Here you have to plot the graph of distance time graph for these scenarios, that car is at rest, car traveling with increasing speed, and that increasing speed is non-uniform speed. Why speed here, not velocity? Because when we have distance and time, we can calculate speed. Then you have to plot the graph that car is traveling with the uniform speed of 5 meters per second. So where you face any difficulty, you can contact me on contact information. Thank you so much. If you have not subscribed the channel, do it, and do not forget to hit the like button.